angle for theta, multiply it by 2, and then take the sine of it. Well, now using this identity, we can now separate it, which is going to allow us to solve equations. It's going to allow us to do some proofs using it. And so these will be given to you on the test. You just have to know how to use them. So some of the problems today are identities, like you're going to have to match up one side with the other. But a lot of today's stuff is solving equations because it's going to allow us to solve these equations that we haven't been able to do before. You might notice that cosine has 3 of them. And why does it have 3? All these are the same. Like, we could prove where all these come from. You can use any of them that you want. Just depends on the problem. But I can show you where these come from. Cosine squared is the same as 1 minus sine squared, right? So if you replace that with 1 minus sine squared, guess what you get? You get the bottom one. 1 minus 2 sine squared. And if you replace sine squared with 1 minus cosine squared, that's where the middle one comes from. So it's just kind of using that Pythagorean identity to get those 3. How do you know which one to use? Sometimes it doesn't matter. And sometimes if your problem has only cosines in it, you'd want to use the cosine one. If your problem has only sines in it, you'd want to use the sine one. And you don't have to worry about memorizing them because I give them to you. It's just knowing how to use them. Okay? So let's look at a problem and see if we can make sense of it. Big thing is directions, especially as we get close to a test next week. Make sure you read the directions. If the directions say prove the identity, that's where you just work with one side and you try to make it equal the other side, no crazy stuff going on. But if it says solve the equation, remember your goal is to get an answer like x equals pi halves or x equals pi thirds, right? That's kind of the goal of that. We did this back in 5.2, but that was before spring break. It's been a while. Our brains have rested a lot since then, so this is kind of some good practice of getting us back into solving equations. Step 1 here is we cannot separate this 2 from this x. You can't divide by 2 and make that 2 go away, which is where the properties that I gave you, or the identities I gave you, are very helpful. Because I could just replace sine of 2x with this, right? So that's kind of the idea today. Most of these are going to start with using one of those properties. So I can replace this with 2 sine of x cosine of x. Notice that u has just been replaced by x. And now remember some rules I gave you back in 5.2. You don't want to divide by sine here. I know you really want to divide by sine. Maybe you even want to divide by 2 sine of x because that's going to make the sine go away and it's going to be so great. But remember, if you divide sine out and you forget about it, then you're missing some answers. And so really subtracting stuff over and getting equal to 0 and factoring is kind of the strategy I want to give you for the most part today. So maybe like a strategy here we could say try to set equal to 0 and factor. That's not going to necessarily work every time, but it's a pretty good strategy most of the time. So I'm going to subtract this over and get 2 sine of x cosine of x minus 2 sine of x equals 0. Someone in the second hour hypothesized that what if you divide by sine, but then you just set that equal to 0 too and see what works. It might work. It seems to work in this one. I'm not a big fan of it, but it does seem to work. So if you like that idea, you could do that. But I think factoring is a pretty good idea here. Because now, this is like what we did back in 5.2. Could I factor out a 2 sine of x out of this? And what would be left would be cosine of x minus 1. And remember, the reason that we like to factor so much is because if you can factor it and set it equal to 0, then you can break it up. You can set this equal to 0 and solve it. You can set this equal to 0 and solve it. Vague memories of this from before spring break? So I can say 2 sine of x equals 0, or I can say cosine of x minus 1 equals 0. And now remember, I'm actually trying to solve for x. So if you divide 2 over, you get sine of x equals 0. And then that's where it goes back to unit circle stuff. Where does sine of x equal 0? Sine is y. Where does y equal 0? At 0 and pi. Do I include 2 pi in this? No, because 2 pi is in parentheses up there. 2 pi is not included. Up to 2 pi, not including it. So 0 pi. And then this one, if I solve this, I just add 1 over, and I get cosine of x equals 1. Where does cosine of x equal 1? Cosine is x, right? At 0, yes? Does cosine equal 1 at pi? That's negative 1, right? It's just at 0, which means we already said 0 over here. In second hour, they were very upset because I didn't write x equals 0 again. But it's the same answer. It's just like if you solve a problem and you get x equals 2 and x equals 2 again. You don't have to write it twice, but you can. But really, there's only 2 answers to this problem. 0 and pi, and 0 again. But, you know, still the same. So, kind of a throwback to what we did before spring break. Good review of solving equations. But the extra part is you have to use these new identities. So, I don't know why I pretend that you don't have this right in front of you, but I hit it. I just like to focus on one at a time. I think that's why I do it. Again, cosine of 2x equals sine x. I can't really do any kind of factoring if there's a 2 in front of that. And so that's where we want to use those identities that I gave you. And this is where you have 3 choices. You can use cosine squared minus sine squared. You can use the one with just sine squared in it. You can use the one with just cosine squared in it. And you can really get there with any of them. You just might have more work to do. Does anybody have a suggestion of which one you think would be a good choice to use? Colton, what do you think? 1 minus. Why'd you pick that one? Yeah, the other side only has sine in it, and remember that if you can get a problem to only have one trig function in it, then you might have a good chance of being able to factor it, so it's better to try to keep it. If you use one of the other ones, you're just going to have to end up substituting using Pythagorean identities to get to this. But try to think about what's my best option when I'm doing this. Again, if you take my advice up here and set it equal to 0 and factor it, I think that's a good idea. Looking ahead of this, is there going to be something you can factor out in front of all this? Because there's a 1, there's a sine squared, and there's a sine. But could I do like some u substitution, like some undoing FOIL where you make the 2 parentheses? You know, I'm thinking like x squared x and the constant. I'm thinking ahead to that, so I'm going to move this over here because I like to keep my sine squared positive. You can just divide through by negative if you want. But I moved this over, so I had a positive 2 sine squared x plus sine of x, and then subtract 1 over, right? I just subtracted 1 and added that over to the other side. Because if I'm going to factor undoing FOIL, I want my squared term to be positive. And this is where you can do u substitution. I don't really like u substitution. But we can do it. I just like to use it for sine. I'll kind of do it both ways here. Because for me, u substitution is just extra steps and extra paper that I don't want to use. Because instead of saying, like, u substitution would say this, 2u squared plus u minus 1. The only difference is u is sine of x. And this is where most of the time we're going to factor by grouping here. If you want to try to factor it without factor by grouping, you can. People tend to struggle with it. And I just have given up on trying to teach that way. So this is where you would do like what multiplies to give you negative 2, that subtracts to give you 1 in the middle, right? Memories of factoring this way. So that would be 2 and 1, right? Plus 2 minus 1. Would give me negative 2 and 1 up there. And this is where you can use u, but for me, I know it's going to be sine, so I just like to put the sine of x in there. Minus 1, bring it down by 2 sine squared. If you like u, use u. If you don't like u, don't use u. I don't like u. It's a joke. In second hour, I said, I don't like you, and they say, I don't like you either. But in here, it might be a little too true to say. No, I mean you guys, not like me. You can factor out a 2 sine of x, and you would get sine x plus 1. Factor out a negative 1, and you get sine x plus 1. Put it together. Do you ever like factoring? Sometimes math people like factoring. I always like factoring, but then this just brings a whole new dimension to factoring when you throw the trig stuff in. I always say factoring is in my top 5 favorite math things to do. And then people want to know what the top 5 is, which I don't really have them like listed out top 5, but definitely crossing things out is one of them. Like when you get to cross, cancel, and mark them out, and you cross all this out and it equals 1. I think that's my top favorite math thing to do. If you get common denominator, just flip it all over, and then you're like, it's 1. Oh my gosh. Could be why I'm a math teacher, but my husband, when he was in college, hated that stuff, and he would get so mad, and he would be like, I did all this work and it equals 1? Whereas I, being a math person, I'm like, look how magical that is. You do all that work and it's 1? Then he would get so angry. Solve this one, you get sine of x equals 1/2. Or you would get u equals -1 and u equals 1/2, and then u with sine of x, so you plug u back in. We're good to here? Not good to here. That's the algebra part, and now it's back to the trig part. Now you got to tell me, where does sine equal -1? 3 pi halves. So we're going. And then this is the harder part. We do better when it's zeros and ones and negative ones. Where does sine equal 1/2? People are still confusing that, but you got to make sure you know that unit circle, and you got to know that sine out here, right? It's 1/2. Pi 6. Sine is y, right? This is square root of 3 over 2, 1/2. So pi 6. And what other quadrant is sine positive in? So what if this is pi 6? What's this? 5 pi 6. We love precalculus. That's exciting, right? Let's do another one. We only have 2 pages of notes left. Two slides. You only have 2 slides left. All right, this one's kind of out there a little bit, so bear with me, okay? We're not proving it. So we could use some identities that I gave you, the cosine squared minus sine squared and all of that stuff. But the difference between number 3 and number 1 and number 2 is this actually just equals a number, right? Could we get this cosine of 2x by itself by dividing 2 over to this side? But be really careful. When I divide by 2, I can cross this out. I can't cross that 2 out. That 2x is stuck up there. But are you with me on that I could say that the cosine of 2x equals 1/2? Now, there are other ways we could do this problem. We could use the identities. I think we could use the one with the cosine squared in it, and we could get cosine by itself, and we could take the square root of it, and we could do a whole bunch of stuff there. But I want to show you a way that I think is easier, but it kind of makes you think a little bit more. Normally, when we solve a problem, we do stuff like this, right? Like, it's just x here, and we say, where does cosine equal 1/2? And we say x equals, and we write the angles, right? That's what we've been doing. The difference here is I got to think about, still, where does cosine equal 1/2? But there's a 2 in front of this. So instead of writing x equals, I'm going to write 2x equals. But still tell me, where does cosine equal 1/2? Pi thirds. No. Oh my gosh. Oh, hey, you got me. I was like, yeah, no. It's this, right? It's pi 6. Yes? No? Oh my gosh. Now I'm a disaster coordinator. I blame you. This square root, no? Yes, 3 over 2, 1/2. I had the coordinates right. I just, oh my gosh. Thanks. This?
Yes.
I know it, I just can't write it. Well, I had it right, I just thought I was wrong. Where else? Sorry, besides pi thirds. always get confused on cosine. What other quadrant is cosine positive? And if pi thirds is the answer, I know it's the same one down here, which is going to be 5 pi thirds. Well, we can write negative pi thirds, but these are the same directions that we're back to one of the last two, which said from 0 to 2 pi. So that's why you wouldn't give negative pi thirds, because the directions tell you what to put it in. If the directions didn't tell you, then you could say negative pi thirds. Okay? You with me on that? Sorry about my circle screw up. Sorry that I blamed you, Courtney. It was all me. I know. This is where 2x equals this. I want to know what x equals. So what do you think I could do? To get x by itself, we could just divide all of this by 2, each of those answers. And when you take pi thirds divided by 2, it's the same as multiplying by 1/2, right? So you're just going to multiply the bottom here by 2, and that's going to be the same as pi 6 and 5 pi 6. And it's kind of weird to think about, because you're like, no, the cosine of pi 6 is not that. But think about what happens when you plug pi 6 in here. What's pi 6 times 2? Pi thirds, and the cosine of pi thirds is 1/2. And so you have to think about, you could think about what angle when I multiply by 2 would give me a cosine of 1/2. But I think it's easier to just think about where does it equal 1/2 and then divide by the number that's in front there. The tricky part is there could still be more angles. Even though 5 pi thirds, the next one's going to be bigger than 2 pi, when you divide by 2, it might not be. So I want you to think about, what if I kept going around the circle? If this is pi thirds, this is 5 pi thirds, that would make this 6 pi thirds. What would be up here if I kept going? 7 pi thirds. Well, we're not going to keep going forever. We just want to go until we get to 2 pi. 5 pi 6 is only like over here, right? So you have to, here's a little trick. Whatever the number is in front here, however many numbers you normally have for your answer, it's going to be that like many extra. So since this is 2, there's going to be double the answers. If there was a 3 in front of this, if normally you had 2 answers, how many answers do you think you're going to have? 6. If there was a 5 in front of it, and you normally had 2 answers, you're really going to have 10. There's not ever going to be a 5 in front of it, unless maybe like a bonus question. Because you always do the same. You're only going to see a 2 in front of it on your homework, I promise. But we could do some that had another number in front of it, and you just have to keep dividing by that number. So for your answer, if there's a 2 in front of it, you're going to need 4 answers. So 7 pi thirds, if we divide by 2, do you agree that that's 7 pi 6? And then what happens if I keep going around? You could just add 2 pi to this, but we could go around. And this is 7 pi 6. No, sorry, 7 pi thirds, 8 pi thirds, 9 pi thirds, 10 pi thirds, 11 pi thirds. Right? That would be 1/3 away from 12 pi thirds, which would be 4 pi. Which would be 11 pi over 6. How do I know I'm done if I didn't know the little trick that 2 means double the answers? Is 11 pi 6 almost 2 pi? So I know if I go any more, I'm back to 2 pi, and I can't go past 2 pi. So that's how I know. But just be aware that there's going to be 4 answers where normally you would have 2 answers. There's one problem on your homework like this, and I'm sure we'll talk about it tomorrow, but I just like to show it to you. I think it's like a shortcut method. How come you can't do that on 1 and 2? The first problems that we did, it wasn't equal to a number. It was equal to another trig function. So it doesn't help to know that trick because you still have to factor in 2 things. But if you have that just equal to a number, then this is a way that you can solve it. Okay? It's not going to be a huge deal, I promise. Maybe a bonus thing. One more slide. These are some other formulas. Again, formulas that I don't think show up very often. I don't think are that important formulas in the whole realm of precalculus and trig stuff. But these are some formulas. If you had a squared and you wanted to reduce it to something that wasn't squared, you could rewrite like this. And then really you could rewrite these using the cosine 2u, and you could really get a big old mess on your hands. But they show up every now and again. I thought maybe we could do one identity here together, not even really using those, but using the other ones. And on your homework today, there's a couple identities. What you want to do today when you're proving these identities, look at what they give you and use these formulas as well as the ones on the front page that I gave you, and look at them and say, do I have a formula that looks kind of similar to this? I don't think it's one of those, so go back to your front page. Is there something on the front page that looks sort of something like this? Cosine of 2u, right, equals 2 cosine of u minus 1, cosine squared u minus 1. Maybe the reason I don't make you memorize these is because I don't have to memorize them. It's probably why I say you don't have to memorize them. All the other ones I have to memorize. You see that that kind of matches this? All you have to do is tell me what u is. What is u in this problem? 3x. So if I was doing this proof, guess what I would write? I would write cosine of 2 times 3x 2u equals 2 cosine squared 3x minus 1. And the super great thing about having these formulas given to you is all you have to do is use that formula now. If this is 2 times 3x, then you can just substitute that in. You can say that that is the same as saying cosine 2 cosine squared of 3x. I don't know why I put parentheses around that. Minus 1 equals 2 cosine squared 3x minus 1. I'm not going to say there's not going to be some that could be a little more complicated than this, but don't overthink them. If they fit directly to a formula, figure out what u is, and then use the formula. And so to how I went from here to here is I just used this direct formula. Like there's really nothing to show there. It's just using the identity. Okay? I will tell you that some of the homework tonight, I think people are going to struggle with it because they're solving equations. And why do people struggle with it? One, we've been doing proofs for so long, we kind of forget to solve equations. And two, you got to be able to get stuff together to factor. You're going to be undoing FOIL. You're going to be substituting in. So try them. Definitely check your answers in the back of the book. And we'll definitely go over problems in class tomorrow. Like we'll probably spend a good 15 minutes at least talking about homework tomorrow because I just know there's going to be a lot of questions. But that doesn't mean don't start it, all right? I also am pretty sure that I'm not going to do 5-4 day 2. I don't know, did I ever give you guys an assignment sheet? I have them here. I think I gave the second hour and not you. Anyway, there's a 5-4 day 2 on the assignment sheet, and I think we're going to skip it. I skipped it last year. I was on maternity leave last year, but they skipped it last year, and I think they were okay by skipping it. And so I think that everything's going to move up, which means tomorrow we're going to have homework questions, and then we'll have a worksheet to just kind of put things together, and then we'll start 5-5 on Thursday, and Friday we'll finish 5-5. And then next week we'll have 5-6, we'll have review, and we're looking at a 2-day test. We're looking at having a test next Thursday and Friday, which means all of your homework from Chapter 5, and there's a whole lot of it. I think it's like 130 points of homework that's going to be due next Friday. So hopefully you're caught up on your homework and don't have 130 problems to do. You're just doing 6 through 27 multiples of 3 and 40. Make sure you pay attention. If the directions say solve it, factor, subtract things over. If the directions say prove the identity, that's where you're trying to match up each side. Okay? And you actually have some time to work. I think I have some papers here I'm going to pass back to you. But get started on this. And like I said, don't freak out if you have a lot of questions because I plan on doing some tomorrow. I'm going to do the whole homework assignment with you, but I definitely plan on going over some with you. Okay?